We're in Chapter 3, Section 5, which is Learning Plan 2.5. We're going to do both relations and functions, and then also function notation and linear functions. So we're going to, first of all, tell the difference between independent and dependent variables, tell the difference between a relation and a function, find the domain, the x-coordinate, and the range, the y-coordinate, of any function, and then identify functions both by graphs and by equations. So let's get started. What is the difference between an independent and a dependent variable? Consider the following. The amount of paycheck for an hourly employee depends on the number of hours worked. So dollars depends on hours. The cost at a gas station depends on the number of gallons delivered, dollars per gallon. The distance a car travels at a certain speed depends on the time traveled. Distance and time. We can use ordered pairs to describe the amounts. The first one is the independent variable. I'm sorry. The number of hours is first, and then, the amount of money is first, and the number of hours is second. So these would be the kind of ordered pairs that we would have. Since the paycheck depends on the number of hours, the paycheck would be the dependent variable. The number of hours is the independent variable. Usually, the independent variable is listed first in an ordered pair. The second coordinate would be the dependent variable. We often describe one quantity in terms of another. Okay, so we've got independent and dependent variables. Now, why is that so important? Because we have to think about how two things are related. One way that we can relate them is with ordered pairs. Age, height, name, first name, last name. Those would be an example of a relation. A function is a special kind of relation. It's a special kind of relation in which when you ask a question, you get only one answer. For every x, there is exactly one y. Not 2, not 3, not 7, but one answer for every question. Okay, so we can look at ordered pairs to determine whether they are functions or not. If you look here, for every first coordinate, is there only one second? No, because if you notice here, if you ask the question -1, one time the answer is 2, the other time the answer is 3. That is not a function. For each question, there is only one answer. Now, some people are tricked because they think, well, the answer is the same. That doesn't matter. For each question, there is exactly one answer. So you do this one. Okay, for each first term, there is only one second term. But in this case, -1, one time the answer is -3, the other time the answer is 6. So we would say no to that question. Okay, this one is a function, because if you notice, there are no repeats there, so we would say it is a function. Here, obviously, it is not a function, because one time you ask the question, the answer is 2, the other time, the answer is 1. Now, a relation and an expression can also be mapped. So, for example, 1 matches 2, 2 matches 5, 3 matches 6. That would be a function. If you look here, 1 matches 2, 2 matches 2, but 2 also matches 6? No, for each first element, there's only one second element. So this would not be a function. So, we can define functions by ordered pairs. Remember, you can only have one first element. for every first element, there's only one second element. You can map it as a correspondence. Remember that you can't have 1 point going to 2 in the second one. You can do it as a table, and we're now going to see by a graph and an equation. Let's see how that works. So for every input, there is exactly one output. This would be a function because there's no way the question x can give you two different answers y. So what is this order in the functions? A domain is the set of independent variables. Now the way I remember it is this is the x-coordinate, this is the y-coordinate, this is the domain axis, this is the range axis. Notice they're both alphabetical. So in this case, give the domain and range represented by the table below. All right, the number of gallons can't be negative, so the domain is 0, 1, 2, 3, and 4. The range is 0, 320, 640, 960, 1280. Those would be the domain and range of that table. Is it a function? Yes, because for each x-coordinate, there's exactly one y-coordinate. Okay, you do this one. The domain is 2, 4, and 6. The range is 2, 5, and 8. Is it a function? No. Why? Because 2 has two different answers. Second one, the domain is 1, 5, 110, and 15. The range is 139, 1039, and 2085. So those would be the two things, and in this case it is a function because for every first question there's only one answer. Okay, you do this one. Now it's kind of tricky with graphs. Remember, this is the domain axis. So the domain is somewhere between -8 and 0. The range is somewhere between 2 and 6. It is not a function, and here's the trick to it not being a function. If I draw, this is called the vertical line test. If I draw a vertical line and it hits it twice, it is not a function. So the domain is -8. It's this one. It's the right answer. Okay, now, this says it's a relation. It's actually a function by the vertical line test. If I draw a vertical line here, I get only one time that I've crossed each axis. The domain is from infinity, -infinity, to +infinity. The range is from -infinity to +4. In other words, it doesn't go any higher than 4, and it is a function. Notice it goes, the domain has arrows, so it goes all the way to the left and all the way to the right. The range is from -2 to infinity and beyond. And it is a function, because the vertical line test, you would cross it only one time. Try this one. Oh, I'm sorry. So when we see graphs, the vertical line test says that if you draw a vertical line, you only cross it one time. So we would say yes here. Here, obviously, there are several places where we cross it twice, where we cross the graph twice. Here and here. Here and here. In this case, we only cross it one time. That's the vertical line test. So in this case, yes, it is a function. Okay? How about this one? No, it's not a function because you cross it. If at any point you cross it twice, it's not a function. So if you see a graph, you can use the vertical line test. If you see an equation, there's something else that we have to do to check if it's a function. Relations can be defined by equations. If it is defined by an equation, the domain can't be 0, because of a fraction, the denominator can't be 0, and you can't have an even root of a negative number. So, for example, the square root of -4 doesn't exist. Graphs that do not represent functions are still relations. All equations in graphs represent relations, and all relations have a domain and a range. So, if you aren't sure what the domain is assumed to be all real numbers that produce real number results. So, decide whether each defines y as a function of x and give the domain. All right, this one doesn't have any square roots, and it doesn't have any fractions, so it is a function. I'm sorry, it has a complete domain. So we would say domain is from -infinity to infinity. Okay, this is, well, it's interesting. Sometimes we speak of this as being the principal square root. I'm going to say it is not a function. And that's because we've got the no, it's interesting. Maybe I will say it's a function. What does the book say? Example 5. Because the square root is a weird thing. Yes, they're saying it is a function because they're saying we're only going to talk about the principal square root. Regardless, you can't have any number less than 0, so it's from 0 to infinity and beyond. Okay, this one. Now, you can have a fourth power. Y to the fourth is x. No, you can't, because you have to write y in terms of x. Y is the fourth root of x. And so we would have to say this is a function. And the domain is from 0 to infinity. This one, y is greater than or equal to 4x plus 2. Since you don't have an equal sign there, it's not a function, but you still have the domain as from -infinity to positive infinity. This one, the denominator can't be 0. Okay? So it is a function, but 5 plus 3x does not equal 0. 3x does not equal -5. X does not equal -3/5, or 5/3, excuse me. So we would say parentheses, -infinity, comma, -5/3, parentheses, -5/3, comma, infinity. So that the only number that doesn't work is -5/3. You do this one. Okay, so it is a function, it is a function, it is a function, it is not a function, and and that's because of the less than symbol. Give the domain from infinity, negative infinity to positive infinity here. Greater than 0 because it's an even square root. From negative infinity, so x minus 2 does not equal 0, which means x does not equal 2. From negative infinity to 2, and from 2 to infinity. Last one, the domain is from negative infinity to positive infinity. Okay, so if we have a function, we can say a function is a relation in which for each value of the first component, there's exactly one value of the second. We can say a function is no first component is repeated. And for a rule, there is exactly one range value for each domain value. Those are the definitions of a function. What are you going to do with that information? Well, page 190 continues with our definitions of functions, and we're going to start talking about function notation. When a function f is defined with a rule using x and y for the independent and dependent variables, we say y is a function of x to emphasize that y depends on x. Now we often just say y is a function of x, or y equals f of x. So in this case, f of x is 9x minus 5. In other words, if it's a machine, for every input it will multiply it by 9 and subtract 5. So if you said 2 is the input, is the x, the machine would say 2 times 9 is 18, minus 5 is 13. So the input 2 would have the output 13. It is a function because there's exactly one answer for each question. So the name of the function is f of x, and the definition is 9x minus 5. So if this is our function, find f of negative 3. Okay, so we're going to take 6 times negative 3 minus 2. 6 times negative 3 is negative 18, minus 2 more is negative 20. So you do this one. So f of negative 2 is 4x plus 3, but instead of writing x, we're going to write negative 2, and we get negative 8 plus 3 is negative 5. So f of negative 2 is negative 5. How about this one? Okay, so it's negative f of negative 2 is negative 2 squared minus 3 times negative 2 minus 2. Negative 2 squared is 4 plus 6 minus 2 is 10 minus 2 is 8. Okay. Now, this one, find f of negative 3. So f of negative 3, instead of writing x, we're going to write negative 3. So negative 3 times negative 3 plus 5 divided by 2. Negative 3 times 3 is 9 plus 5 divided by 2 is 14 divided by 2 is 7. F of t, so instead of writing x, we're going to write t. Negative 3t plus 5 over 2. Now we can't simplify it any more than that, so that is our f of t. Okay, you do this one. So for a, f of negative 2 is 2 times negative 2 squared minus 4 times negative 2 plus 1. Negative 2 squared is 4 times 2 is 8. Negative 4 times negative 2 is positive 8 plus 1 is 17. f of a, instead of writing x, we're going to write a. 2a squared minus 4a plus 1. Now you may say, why am I ever going to need to know that information? Well, I'll tell you this. It becomes easier when you see it in action as to how that takes place. Now, this one's a little bit tougher because instead of substituting in a number, we're going to substitute in a more complicated equation. So g of m plus 2 is, instead of writing x, we're going to write m plus 2 minus 1. So we wrote the 5. Instead of writing x, we wrote m plus 2, and we wrote the 1. 5 times m is 5m. 5 times 2 is 10, minus 1 is 5m plus 9. So g of m plus 2 is 5m plus 9. Try this one. Okay, so g of a minus 2 is 8 times a minus 2 minus 5. 8a minus 16 minus 5. 8a minus 21. So g of a minus 2 is 8a minus 21. So f of k minus 1 is 4 times k minus 1 squared plus 3 times k minus 1 plus 1. K minus 1 squared is k squared minus 2k plus 1 plus 3 times k minus 1 plus 1. So this is 4k squared minus 8k plus 8 plus 3k minus 3 plus 1. So we get 4k squared. Combine these two, you get minus 5k. Combine these two plus, oh, this should be 4, excuse me, not 8. Plus 5. No, that's not one of the choices. Oh, this is minus 3. So 4 minus 3 is 1, plus 1 is 2. So 4k squared minus 5k plus 2. Okay. Example 4, find f of 2. In this case, what is, when f is 2, x is, so we would write f of 2 equals 6. In this case, f of 2 is negative 2 squared, which is negative 4. Okay? Next one. So find f of negative 1 when x is negative 1, y is 4. F of negative 1 here is negative 1 squared minus 12. Negative 1 squared is 1 minus 12 is negative 11. Next one. Find f of 2. F of 2 in the first case is 8. Oh, that is the only case that we've got. Okay, so try this one. F of 2, so where x is 2, y looks to be, f of 2 is 1. F of negative 2 is 3. Oops, negative 2 is 3. For what value of x is f of x 0. So where do we cross the 0 axis? Looks like about 4, huh? F of 4 is 0. Next one. F of negative 1 is 0. Is f of x 2? Looks like it's 2 here at 1. F of 1 is 2. Next one. F of negative 1 looks to be about negative 3. Okay, so when you are looking for function notation, solve the equation for y and replace y with f of x. So rewrite the equation using function notation and then find f of 1 and f of a. We want the y all alone. So we have, let's subtract x squared from both sides. And we get negative 4y equals negative x plus 3. Divide both sides by negative 4. And we get y equals, this is a squared by the way, y equals x squared over 4 plus 3/4. And now we're supposed to write it in function notation, so we would say f of x equals x squared over 4 plus 3/4. Find f of 1. F of 1 equals 1 squared over 4 plus 3/4. 1 squared is 1 over 4 is 1/4 plus 3/4 is 1. And then f of a is a squared over 4 plus 3/4. So that's how you do those. Try this one. So getting in an f of x notation, add 4x squared to both sides. We get y equals 4x squared plus 5. F of x equals 4x squared plus 5. F of negative 3 is 4 times negative 3 squared plus 5. Negative 3 squared is 9 times 4 plus 5 is 36 plus 5 is 41. So f of negative 3 equals 41. Now, f of h is, go back to this, 4h squared plus 5. I think this is the last one. So we get 7y equals negative 9x squared plus 6. Divide both sides by 7. And we get y equals negative 9x squared plus 6 over 7. F of x equals negative 9x squared plus 6 over 7, which is this one right here, b. Oh, I'm sorry, I forgot that we had to graph linear equations, or linear functions. So when we graph them, this is the slope, this is the intercept. It's pretty easy. In this case, though, there is no slope, just an intercept. So we intercept at negative 1.5, and the slope is 0. Are we supposed to, oh, and we're supposed to give the domain. Domain is negative infinity to, that's infinity, to infinity, and the range is negative 1.5. Next one, you do this one. So the intercept is negative 2, slope is 1/3. Give the domain. domain is negative infinity to positive infinity, and the range is also negative infinity to positive infinity. Because if you notice, both of them have arrowheads, so it goes all the way down, all the way up, all the way left, and all the way right. Next one. Negative or positive 3, from there go down to forward 1. So there's our line, and the domain is negative infinity to infinity, and the range is also negative infinity to infinity.